Welcome to the Explainer. Right now there's actually a hidden battle going on inside the walls and basements of homes all across the Pacific Northwest. Today, we're breaking down the wild clash between the unique microclimate of Sammamish, Washington, and the aging 1990s-era home heating and cooling systems that are just struggling to survive it. If you've been wondering why your furnace is constantly running or why your energy bills are creeping up, well, the answer is literally written in the weather and the dirt right outside your door.
Okay, let's dive into this. We're going to hit the Sammamish microclimate, common HVAC casualties, the economics of repair versus replacement, those strict new building codes, and finally, a specialized three-step service process to fix the whole shebang.
Let's start with the root of the problem. Section 1. The Sammamish microclimate. So Sammamish isn't your average Seattle suburb when it comes to the weather. It sits right in this unique geographic clash where the foothills of the Cascade Mountains meet that heavy moisture rolling off Puget Sound. And this creates some serious seasonal whiplash for your home's mechanical systems. Think about the winter. Mornings routinely drop below freezing, right? But then the afternoons suddenly shoot up into the 40s. Your furnace isn't just turning on and staying on, it's constantly cycling on and off, day in and day out. Then flip to the summer. We're getting weeks of dry 85-degree heat with absolutely zero rain. Your AC has to run nonstop, fighting off massive amounts of dust kicking up from the dry perimeter around Lake Sammamish.
And it gets even crazier because these hazards are hyper-local. It literally changes neighborhood by neighborhood. Up in Sahaleh and Pine Lake, you've got this clay-heavy soil that physically shifts with seasonal moisture, completely stressing out the outdoor equipment. Down by Beaver Lake, homes trap tons of moisture in their crawl spaces, which actually corrodes the ductwork. Up on the Sammamish Plateau, homes face severe western winds that physically loosen exterior condenser units. And near East Sammamish Lake, high humidity just accelerates rust and mold on the metal parts. Your zip code is basically dictating exactly how your HVAC system gets attacked.
Which brings us to Section 2, Common HVAC Casualties. And this brilliantly illustrates what happens when this intense microclimate meets the thousands of homes built during the 1990s Sammamish building boom. Places like Trossachs and Timberline, they fail in a highly predictable sequence. These original 90s systems are pushing well past their 15-year lifespan. When the weather stresses them out, they break down in stages. First, the capacitors wear out. Once those go, the blower motors are forced to work overtime until they fail. And finally, the absolute heart of the system, the compressor, just completely dies.
But what's really alarming is the physical damage going on behind the scenes. Those winter freeze-thaw cycles we just talked about, they force the metal heat exchangers in older furnaces to expand and contract until they crack. That is absolutely crucial because it can leak deadly carbon monoxide right into your living room. Meanwhile, summer dust clogs up your AC evaporator coils, instantly slashing your cooling capacity by 30%. Shifting clay soil cracks the refrigerant lines. And to top it all off, a lot of these 90s homes have undersized ductwork that chokes off the airflow right out of the gate. Moving right along to Section 3, Repair versus Replacement Economics. With all this mechanical carnage, we really need to talk about the money, because at a certain point, fixing a broken machine is just a terrible financial investment. And that whole financial decision, it really boils down to one magic number, $5,000. In the industry, this is known as the $5,000 rule, and it's basically the ultimate cheat sheet for homeowners. Here's how it works. You take the age of your HVAC unit in years, and you multiply it by the estimated cost of the repair. If that number hits over $5,000, you should absolutely replace the unit instead of fixing it. So let's say you've got a 15-year-old furnace in Timberline, and it needs a $400 repair. 15 times 400 is $6,000. That is over the threshold, meaning throwing $400 at a dying system is a bad move. Getting new equipment is going to give you way better long-term value. You also have to keep average lifespans in mind. Furnaces generally give you about 20 to 25 years. Air conditioners, maybe 12 to 17 years. Heat pumps, which have to work year-round for heating and cooling, only last about 10 to 15 years. And because of Sammamish's damp climate and that constant cycling we talked about, systems here are almost always pushed to the very low end of those lifespans. So if you do have to replace it, what's the actual damage to your wallet? Well, for a standard 2,000 square foot home, adding central AC to existing ducts runs about $4,500 to $9,000. A heat pump installation is somewhere between $7,000 and $15,000. And replacing the whole shebang, a complete HVAC system, ranges from $8,000 to $18,000. Pro tip though, the absolute best time to do this is in the fall or spring when demand drops. Plus, looking ahead to 2025, the Inflation Reduction Act can actually hook you up with up to $2,000 in federal tax credits if you go with qualifying Energy Star systems.
Okay, Section 4, strict HVAC code requirements.
Now, what's really interesting about this is that replacing a system isn't just swapping out a metal box anymore. Washington state does not mess around with energy efficiency. Take the manual J-load calculation, for instance. Back in the day, contractors would just eyeball the square footage and guess what size furnace you needed. Yeah, no way. That is totally unacceptable now. A manual J calculation measures your specific climate zone, insulation values, window area, air leakage, the whole 9 yards. If a system is oversized, it short cycles and fails to dehumidify. If it's undersized, it runs constantly. Getting this calculation dialed in is the only way to get even heating and cooling.
Sammamish is super strict about the 2021 Washington State Energy Code, which means you need city permits and inspections for sure. You have to meet minimum efficiency standards. Duct sizing has to follow ACCM Manual D standards, which is a huge deal, because those undersized 90s ducts we keep mentioning, they usually fail these modern calculations and have to be heavily modified. Oh, and carbon monoxide detectors are absolutely mandatory. Plus, anyone handling your refrigerants has to carry an EPA Section 608 certification.
And why is that EPA certification such a big deal? Because of this number, 70%. Up to 70% of an air conditioner's efficiency loss, and the #1 cause of premature compressor death, is just from improper refrigerant charging by uncertified techs. Guessing the refrigerant levels literally destroys the equipment. Crazy, right? Which perfectly sets up our final section, Section 5, the 3-step service process. Let's move to and see how this builds into a foolproof service model designed specifically for the Sammamish area. Companies like Peak HVAC Seattle use a structured approach with 3 distinct steps: immediate dispatch, accurate diagnosis and repair, and system verification. First up, speed and prep are everything. Peak HVAC Seattle makes sure their techs live locally. We're talking Issaquah, Redmond, Bellevue, so during an emergency, they aren't stuck fighting cross-lake traffic from Seattle. They're there in 2 hours. And better yet, they roll up with trucks packing $15,000 in inventory, carrying over 200 parts specifically for the equipment in Sammamish developments. They know exactly what breaks in these neighborhoods, which is why they fix 87% of issues right on the very first visit. Step 2 is diagnosis. And guess what? No guessing allowed. They use digital manometers for exact airflow, refrigerant scales to nail that EPA-compliant charge perfectly, combustion analyzers to make sure the furnace is totally safe. This measured, calibrated approach completely wipes out that old, frustrating trial and error method of just swapping parts until the machine magically turns on. You get upfront pricing based on hard data. And then step 3 is verification. They actually document the temperature splits to prove the system is running exactly to the manufacturer's specs before they ever pull out of your driveway.
So, after breaking down the brutal Sammamish microclimate, the incredibly predictable ways these older systems die, and the super strict codes needed to fix them, the final question goes to you. Does your home's 1990s HVAC system actually pass the $5,000 rule? If you're living in one of these older homes and those repair bills are starting to stack up, it might just be time to run the math before the next massive summer heat wave or freezing winter morning decides for you. Thanks for joining me on this explainer, and I really hope this helps you stay comfortable and financially savvy all year round.